India's maiden interplanetary mission, the Mars Orbiter mission, MOM, also called Mangalyaan, marked a major milestone in its space program. Launched in November 2013 by the Indian Space Research Organisation, ISRO, Mangalyaan created history by successfully entering Mars orbit on its very first attempt. Key objectives included demonstrating India's capability to reach Mars orbit and conducting scientific studies on Mars surface features, morphology, minerals, and atmosphere. The Mangalyaan mission is considered historic for being India's maiden interplanetary voyage executed in the very first attempt. It put India in an elite club of global space agencies with expertise in Mars exploration. Mission Mangalyaan, launch details and timeline. The launch and insertion phase required very precise maneuvers by Mangalyaan involving both terrestrial and deep space navigation over 10 months. Mangalyaan was launched aboard a Polar Satellite Launch Vehicle, PSLV-C-25, rocket from Satish Dhawan Space Center at Sriharikota, Andhra Pradesh. The spacecraft spent over 300 days cruising in deep space before entering Mars orbit on September 24, 2014. This was achieved in the very first attempt, a historic first for any Asian space agency. Initially planned as a 6-month mission, MOM completed 8 years in Mars orbit on September 24, 2022, well beyond its designed mission life. Parts of the Mangalyaan mission. After entering orbit, the scientific phase involved Mangalyaan started collecting data through 5 onboard payloads to study Mars surface, atmosphere, and mineralogy. Orbiter. Mangalyaan orbiter weighed 1,337 kilograms with a lift-off mass of 1,340 kilograms from Earth. It had a cuboid structure with solar panels attached to facilitate power generation. Payloads. The orbiter had 5 payloads to conduct scientific studies using multiple instruments. These include Mars Color Camera, to capture images and information about Martian surface features and processes. Methane Sensor for Mars, to detect the presence of methane which would provide evidence of Martian life. Mars Exospheric Neutral Composition Analyzer, to study the composition of the planet's upper atmosphere. Thermal Infrared Imaging Spectrometer, to map surface composition and mineralogy of Mars. Lyman Alpha Photometer, to measure the relative abundance of deuterium and hydrogen from Lyman alpha emission in Mars exosphere. Objectives. Scientific. Mangalyaan was developed to build deep space exploration capabilities and conduct a study of the Martian surface features, morphology, mineralogy, and the atmosphere, as well as to study extraterrestrial life. Technological. It aimed to develop, test and validate the state-of-the-art technologies capable of operating with sufficient autonomy in the journey phase of interplanetary travel. Scientific findings of Mars Orbiter mission. During the extended mission phase spanning over 8 years, the MOM payloads have contributed important Martian observations. Atmospheric methane detection. Methane sensor for Mars made the first clear detections of Martian methane, a potential indicator of microbial life, in September 2014, raising prospects of potential biological links that warrant deeper investigation to isolate sources. Surface imaging. High-resolution images from the Mars Color Camera delivered extensive visual data on Martian surface features like craters, valleys, dunes, ice caps, and weather systems, facilitating a better understanding of surface morphology and dynamics. Mineralogical mapping. Thermal infrared imaging spectrometer generated mineral composition maps of Mars surface showing distributions of clay, hematite, silicates etc. tied to past aqueous alteration processes, providing clues to paleoclimatic conditions. Upper atmospheric insights. Menka mass spectrometer facilitated precise quantification of the extent of argon-40 in Mars atmosphere, a tracer isotope giving clues on atmospheric loss to space. Mission Mangalyaan challenges and solutions. Despite meticulous planning, the Mangalyaan mission team also had to overcome key challenges during the long voyage and continuing orbital phase. Communication time delay. Earth-Mars distance of 200 to 400 million kilometers implies a one-way radio signal delay of at least 4 to 20 minutes, demanding reliance on automated fault detection, diagnosis, and correction capabilities without ground control guidance. Propulsion needs. Lack of onboard propulsion system implied trajectories had to be perfectly pre-calculated, including factors like slingshot maneuvers. Mid-course corrections were done using short thruster bursts. Solar conjunctions. When Mars goes behind the Sun relative to Earth, ionized solar plasma can interfere with signals. So special automated contingency procedures were formulated. Mission Mangalyaan made core improvements in automation, autonomy, and onboard decision-making functions to resolve situations without immediate ground control while advancing deep space communication abilities. Significance of Mangalyaan mission. The success of Mangalyaan had wide-ranging impacts on the trajectory of India's space program. Mastering interplanetary skills, highly complex coordination to complete manufacture, assembly, integration, testing, launch and spaceflight operations within 18 months reflected robust mission engineering skills. Platform for advanced exploration. Operational validations of enhanced spacecraft technologies will lay the foundations for highly capable Mars missions in the 2030s timeframe, involving attempting historic landing and roving milestones. Boosted priority for space exploration, leading to approval of subsequent proposals like Chandrayaan-2, Aditya-L1, Shukrayaan-1, etc. Spur commercial space activity. The mission's result will highlight the proven reliability of India's space technology for global customers while catalyzing both international partnerships and the domestic private space industry. Cost reduction. Economically executed mission, 4.5 Bn rupees, using limited engine firings and optimized for fuel, weight etc. Won international acclaim, contrasted to contemporary NASA Maven orbiter's 10 times higher price tag. Global leadership. India is staking leadership among developing countries rather than mimicking other agencies in advancing Martian exploration. Entry into the elite league of space agencies mastering expertise in Mars travel, boosting global standing significantly. Global Mars missions. Since the first successful flyby in 1965, several space agencies have successfully made it to Mars, such as mission name. Key highlights. Current status. Mars Express European Space Agency, 2003, the first European mission to Mars, found evidence of methane and ammonia, operational since 2004, extended until the end of 2022. Curiosity NASA, 2011, rover analyzed geology and climate, and found evidence ancient lakes could have supported life, active and mobile on Mars. Maven NASA, 2013, orbits Mars studying atmosphere and climate history, operational, has helped relay data from rovers. ExoMars Trace Gas Orbiter, European Space Agency/Russia, 2016, studies atmospheric gases like methane, relays data from rovers, operational at Mars, has detected unusually high methane levels. InSight Lander NASA, 2018, geology mission assessing seismic activity on Mars, operational on Mars surface, has recorded over 500 Mars quakes so far. Hope Mars mission United Arab Emirates, 2020, first interplanetary mission by Arab country, atmospheric studies, successfully entered Mars orbit in 2021. Tianwen-1 China, 2020, China's first independent Mars mission containing orbiter, lander, and rover. Rover Zhurong operational on Mars surface after 2021 landing. Mars 2020, Perseverance rover NASA, 2020, seeks ancient signs of life, carrying Ingenuity helicopter drone, operational on Mars, has recorded archaeological sites, Ingenuity completed flights. Mangalyaan 2. The Mangalyaan 2 mission is set to explore Mars and will carry 4 payloads to study various aspects of the Red Planet. These payloads include the Mars Orbit Dust Experiment, MODEX, Radio Occultation, RO, Experiment, Energetic Ion Spectrometer, EIS, and Langmuir Probe and Electric Field Experiment, LPEX. The study will focus on the Martian atmosphere, environment, and interplanetary dust.